NCERT Physics Class 11, 6th chapter, which is Work Power Energy, question number 6.25. In this, we are given two frictionless tracks are given to us. One is gradual, another is steep. If meet at point from where the two stones are allowed to slide down from rest. The initial velocity of both the stone is 0, 1 on each track. While the stone reaches to the bottom at the same time, he is asking, will the stone reaches the bottom at same time? That the time of journey for both the stone is same or different. We have to find out that. Or another part, will they reach there with the same speed? So when they reaches bottom, the speed we have to, the order of speed we have to find, and the time taken by them we are supposed to find out. So what is the speed and what are the time taken by the stones when they reach ground? So in this we have two stone, which is 1 and with another is 2. Now taking to first one, that is, let's say, first stone. So the height of this steep is 10 meter. It is given that this height, this vertical height is 10 meter. Now coming to first stone, for first stone. So for first stone, we can find out the value of acceleration as the force acting along the incline is equal to mg sine theta 1, and theta 1 is equal to 30. So we can find out the acceleration of first particle by using equation F is equal to m into a. Sine theta 1 is equal to m into a1, where acceleration a1 is equal to acceleration of particle 1 along the incline. So a1 comes out to be g sine 31, that is equal to g into sine 31, that is equal to sine theta, and theta 1 is equal to 30 degree, and sine 30 is equal to 1 by 2. So a1 is equal to g by 2. Now moving to next one, for stone 2 we have now we are using the equation for second stone, which is for second stone we can say that the net force acting on the stone is mg into sine theta 2, and the value of theta 2 is equal to 60 degree. So from this we can find out the value of a2 as a2 is equal to g into sine theta 2, and the value of theta 2 is 60. So sine 60 can be written as root 3 by 2. So the value of a2 comes out to be root 3 into g by 2. So a1 is acceleration of first stone along the incline, and a2 is acceleration of second stone along the incline. So from this we can find out the value of a1 and a2. Now in order to find out the speed when they reaches the bottom, so this can be find out by using the concept of work energy theorem. So the track is frictionless, so there is work done. The work done is only due to gravity, as normal is perpendicular, so work done by normal is 0. Work done by friction is 0. So only force which is acting on the system, that is gravitational force. So work done is equal to change in kinetic energy. Work done can be written as change in kinetic energy. So work done by gravity is equal to mgh, where h is vertical height, that is equal to change in kinetic energy half m into v square minus change in kinetic energy final minus initial half m into u square. As it is given that the particle start from rest, so the value of u is 0. So we can say that the final velocity on reaching the ground, that can be given as under root of 2gh. So in both the situation, either for stone 1 or stone 2, the height is same, g is same. So speed for stone 1 is equal to speed for stone 2, and this value is equal to v. And the value of v is written as under root 2gh. Now putting the value of g and h, we can find the value of speed at the bottom. So v is equal to, value of g is equal to 9.8, and the value of h is equal to 10 meter. So it comes out to be under root 196, which is equal to 14 meter per second. So speed of both the stone on reaching the ground comes out to be 14 meter per second. Now the second part, the time we are supposed to find out. So for first situation, that for first stone, the time can be written as, for first stone, the time can be found by using equation of motion along incline. we are using equation of motion along the incline. So along the incline, the v equal to u plus a into t. As you know, the initial velocity is 0, the final velocity v, which comes out to be 14, and the acceleration, which is equal to 9 point, sorry, the acceleration in first situation, the acceleration in first situation comes out to be the final speed, that is 14, and acceleration in first situation, that is a1, and the value of a1 is equal to g by 2. This is equal to t1. So the value of t1 comes out to be 28 upon 9.8. And on solving this, the value of t1 comes out to be 2.86 second. And for the second situation, for second stone, again we are going to use the equation along incline, and when you use equation along incline, v equal to u plus a2 into 2 into t, and let's say this time is t2. So a2 is acceleration of second stone along the incline, and initial velocity is 0, final velocity is 14. a2 is equal to root 3 g by 2 along incline into t2. So from this we can find out the value of t2 as t2 comes out to be 14 into 2 upon 9.8 into root 3. On solving this expression, t2 comes out to be 1.65 second. So from this we can clearly say that the time taken by first stone is greater than time taken by second stone.